This is all about logarithmic and exponential equations and how we solve them and solve the inequalities that are like them. I'm getting the calculator prepared right now. It's popping up on the screen as we speak. And let's move it over to the side so it'll be out of the way. All right, so our equation is 2 times the quantity 4 to the x minus 128. And our goal is to figure out what is the value that makes this function equal 0. What is the value of x? So let's figure it out. Let's set it equal to 0. Move the 128 over to the other side, and that's going to give us 2 times the quantity 4 raised to the x power is equal to 128. Seems simple enough. Now let's make it even simpler by dividing both sides by this 2. Anytime we can make our equation smaller, we should do so. So now we have 4 to the x is equal to 64. Now, if you know like I know, 64 can be written in terms of 4. 4 to the second power is 16, but 4 to the third power is 64. So that means that the answer to our question, once we drop these 4s like they're hot potatoes, is x is equal to 3. So that's the answer to the first of 3 parts. Where does f of x equal 0? It equals 0 at x equals 3. We solved it. Now it says use the graph. Now I don't know about you, but I don't see any graph, but our calculator can help us with that. So we're going to go over to y equals, and we're going to type in this screen. Let's clear this out. I've had so many equations in here today that it's amazing. So I'm going to come up here, and I am going to type 2 parenthesis 4 raised to the x, close my parenthesis, minus 128. I'm going to type the exact function into my equation. Now, I already know that my solution is 3, and I kind of know that if I plug in a 0, I'm going to get something that's really, really, small, but let's go ahead and hit graph and see what we get. And see, I don't get to see the fullness of my graph because I know that if I plug in a 0, I get 4 to the 0, which is 1. 1 times 2 is 2. So that means that my y-intercept is negative 126. So if I want to see the full graph, the full Monty, I need to change this window a little bit. So I'm going to go over here and make my y-min something like negative 130. Just so I can see some extra stuff. Maybe I'll even go to 150 to be, extra about it. And I'm going to count by, maybe I'll count by 20s. Nah, I'll make it 10, so it'll be kind of even. And negative 10 to 10 should be okay because my answer is 3, when it goes through the axis. So I'm going to hit graph. And now you can see a little bit more of the graph going downward, even though it only went up to like 10. You see it only went up to that 10. So I can make it go up to 150 so you can see more of it. But it isn't really necessary. But I guess I could go up a little higher. Let's make my y max more than 10. Let's make it 100. Now you can see more of the graph. All right, now the question says, where is f of x, which is this blue graph, greater than 0? 0 is the x-axis. Now, of course, where it's greater than 0 is where the y values are positive. Now, the question is not asking you what y values are positive. It's asking you, in terms of the domain, what x values exist for which this graph is greater than 0. So we're looking for the x values where this is greater than 0. So it's everything from here all the way to positive infinity. So the answer to this question is going to be, including this answer that we found, because we're looking for, well, I did the greater than part, so let's do the less than part. So for the less than part, it is actually from this 3 all the way back to negative infinity, because this is where all the negative y values are. You see that? And we've got our horizontal asymptote right down here at negative 128. That's what that number is. But anyhow, nobody asked me that. So we're going from negative infinity to 3 with a parenthesis because it says less than 0, not less than or equal to, less than 0. Now this one says greater than or equal to 0. So now we're going to start with 3 where it equals 0 and go to positive infinity. So this is the answer to this portion, and this is the answer to this portion. And it's all about graphs. And often that's the place where folks kind of mess up in terms of how does that graph look? I don't understand. That's what it is. All right, now we're looking at 37, which is in the last unit that we learn in this class. Number 37 is about solving nonlinear systems. And as you can clearly see here, we have a circle and a line. And a circle and a line can intersect in 1 point or in 2 points. It could be tangent or it could be a secant that goes through 2 points. So the problem with this is that we can't just solve a typical system where we could just cancel out a variable because the variables are all different. On the top, they're squared. On the bottom, they're raised to the first power. What? So what do? We're going to start with the linear function, and we're going to solve for a variable. So we're going to start with equation number 2, and I'm going to solve for x. I'm going to say x is equal to 10 minus y. All right, so far so good. Nobody has fallen out yet, have they? Very good. X is equal to 10 minus y. Now what do? Well, we're going to take this 10 minus y and we're going to substitute it into this equation. So we're going to substitute. We're going to use substitution. This isn't a substitute teacher. It's just we're going to substitute wherever I see an x. Now, it's probably spelled wrong. You know math teachers, we can't spell. But we're going to substitute 10 minus y in for x in the first equation. We're not going to substitute into the second because we'll just end up with 10 equals 10, and that's true. But we want to substitute it into the other one. So let's go for it. I'm going to use blue ink to substitute it in. So everywhere I see an x, I'm going to put 10 minus y. And I'm going to square it because it told me to. So remember, I'm plugging into x squared plus y squared equals 68. All right, so now I can say plus y squared equals 68. Now, I can't be like some of my students of the past that took 10 minus y squared and wrote 100 minus y squared. I have to actually FOIL it. 10 minus y times 10 minus y. Make a box, make a friend, make a plan, start to pray, do what you do. And you're going to end up with 100 minus 20y plus y squared. If you don't believe me, make a box. And if you do know how to distribute or do reverse FOIL or just multiply with some loops, you can do that. But all we do is we say 10 times 10 is 100. 10 times negative y is negative 10y. Negative y times 10 is negative 10y. And negative y times negative y is positive y squared. You put your like terms together. You've got y squared, and that equals 68. All right, now, over on the left side, we can take our time and actually combine like terms. And I'm putting descending order too. 2y squared minus 20y plus 100 equals 68. And all I did was put the biggest exponent first and the constant term at the end. Now we're going to subtract 68 on both sides. And now we've got 2y squared minus 20y plus 32 is equal to 0. Now, what are we going to do at this point? Factor out a 2. Or, as some folks would do, we could just divide out a 2. When we do that, we are left with, and we'll put it right up here, y squared minus 10y plus 16 is equal to 0. Okay, here we have it, a lovely quadratic. How will you solve it? You can factor it, complete the square, graph it, you can use the quadratic formula. You've got a lot of methods under your tool belt. I'm going to factor it because I believe that things can be factored. Sometimes they can't, but I believe this can. So I've got y, and I've got y. 16, what multiplies to give me a positive 16 but adds to give me a negative 10? I'm thinking negative 2 and negative 8. So y equals 2 and y equals 8. So that's good for y. But what about x? Now what do? We've got to go all the way back to the beginning where we said that x was equal to, you guessed it, 10 minus y. Now we can figure out what x is. Let me make this real extra looking. That prettied it up. All right, so now we're going to do x is equal to 10 minus 2, which means this x is 8. Now, when you write out the ordered pair, it's going to be delightful. I'm going to put it right up here where I had my little foil explosion. So my answer is going to be 8, comma 2. That's one of my answers anyway. Now for my other answer. When y is equal to 8, this time we have x is equal to 10 minus 8. And you've got to do both of them. This time x is equal to 2. So that means the other possibility would be going through the point 2, comma 8. And then you could plug it in, but clearly you know that 10 minus 2 is 8, and 10 minus 8 is 2, so it works in the linear equation. 8 plus 2 is 10. When you go to the top, 8 squared is 64, 2 squared is 4. Add them together in either order, you're going to get 68. So this is our answer. That was a lot of work. A lot of work for nonlinear systems. All right.